Now vector algebra and vector analysis. This is important topic in physics as well as in mathematics, and it is required in different fields of physics. So here we will go to first what is vector, what is scalar. So what is a scalar? Scalars are quantities that are fully described by a magnitude or numerical value alone. That quantity, physical quantity, is called scalar. And we know number of examples. For example, mass. Mass is a scalar quantity. Then volume is a scalar quantity. Temperature is a scalar quantity. Then we can have distance. Is a scalar quantity. And these quantities are described by its magnitude or numerical value only. Like mass is 1 kg, volume is 4 meter cube, temperature is 25 degrees Celsius, distance is 2 meter, like this. And vectors are quantities that are fully described by both magnitude and direction. That quantities are called vector quantities. So if we see here example, here we have velocity. It is a vector quantity. Force. It is a vector quantity. Then you can have displacement. Is a vector quantity. So here these are vector quantities. To describe these quantities, we require its value as well as its direction. So this is difference between scalars and vectors. Scalars, they are expressed in terms of numerical values only, while vectors, they require magnitude, means value, as well as its direction. Now let us take simple xy plane here, and suppose we take body of some mass m, and suppose this body, it is moving on xy plane. It is moving on xy plane. So this is path, and suppose this is starting point and this is end point. And when it is moving along path at some time t, this is the position. This is the position at time t on xy plane, that position on xy plane. Now at this point, the body will have some velocity. Then what is value of that velocity and what is direction? So that velocity, it is expressed in terms of a vector quantity. If we take another position, so body goes from this position to this position. So there is displacement from first position to second position. So that displacement is also vector quantity because it has direction. Here body will have velocity and that velocity will have some direction. If body comes here, it has velocity at that point, and direction of velocity, it is tangential to the path. When it is here, velocity is tangential to the path. When it is here, velocity, it is tangential to the path. So direction is important here. Direction is important here. And what happens from, suppose we take this point A and point B. So here this path gives you total distance traveled by the body. But what is displacement? We take this as the displacement. So to find displacement, we take initial position and final position. So distance and displacement are two quantities that may seem to mean the same thing, yet have distinctly different definitions and meanings. Distance and displacement are two quantities that may seem to mean the same thing, yet have distinctly different definitions and meanings. Distance is a scalar quantity. Distance is the total movement of an object without any regard to direction. So when we say distance, we do not consider its direction. It refers to how much ground an object has covered during its motion. And displacement is a vector quantity. It is defined as the change in position of an object. It is the object's overall change in position. So that is difference between distance and displacement. Distance is a scalar quantity, displacement is a vector quantity. Now we will see example. Here I have taken one body. Suppose initially it is at position A. It is at position A. And suppose this body moves along this direction. So it goes up to B. It goes up to B. Then it moves along this direction. It goes up to C. Then it moves along this direction. It goes up to D. And then it moves along this direction. It goes up to E. Then what is distance traveled by the body? And what is displacement? What is displacement? So here distance means here it is the total movement of an object without any regard to direction. So A to B distance. So total distance means distance, it is equal to distance traveled. It is AB plus BC plus CD plus DE. DE. This is distance. Maybe suppose 5 meter, 2 meter. Here it is again 3 meter, and suppose it is 2 meter, like this. So here total distance 5 meter plus 2 meter plus 3 meter plus 2 meter. So it is 12 meter. 12 meter. It is the distance traveled by the body. What is displacement? So it is defined as the change in position of an object. So what is initial position? This one is the initial position. And this E, it is final position. Final position. And displacement, it is the object's overall change in position. So it goes from A to E. So join that, A to E. So AE is displacement. AE is displacement. And it is along AE. AE is displacement, that is along A to E. Now you can find this distance AE, distance AE. You can find. Now this distance AE, it is along AE, so it is a vector quantity. So by using geometry, you can find distance AE. So see here, this one is, if we take this, this is 2 meter and this is 2 meter. So suppose I take here some F. So FD, it is 2 meter, DE, it is 2 meter. So EF, it is 4 meter. Now what happens? AF is equal to how much? AF is equal to, we know AB is 5, CD is 3, so remaining is 2. So it is 2 meter. So this is 2 meter. So you can, now this is right angle triangle. So we will get AE square is equal to AF square plus FE square. Means AE square is equal to AF, that is 2 square plus 4 square. 2 square is 4 plus 16, that is 20. So AE square, it is equal to 20. So AE is equal to root of 20. Root of 20 meter. So this is distance between initial position and final position, and this is along AE. So AE, displacement is represented as vector AE having magnitude root of 20 meter. Having magnitude root of 20 meter. So in this way we define distance and displacement. We define distance and displacement. So here now we will see another vectors. I have taken spring mass system here. So here in relaxed mode, means here we have mass M, means block of mass M. It is placed on the horizontal surface and spring is attached. So one end of spring is attached to block here, another end is attached to support, and we keep as it is. That is called relaxed mode. So the position of the mass is considered as equilibrium position. So and I will call this as x is equal to 0. So this is equilibrium position. This is equilibrium position. Now if we, let us go to second figure. Same spring I have taken, same one is taken here, and suppose we extend, we move mass. We move mass towards positive side. So what happens here? This spring is extended. So here it is extended along this direction. Here x is given, x is extension. So it is along this direction. So this one is vector quantity. Now what will happen? Force will act due to spring on mass M. So I have shown here direction of force. So here force, it has direction. It has direction towards equilibrium position. Towards equilibrium position. Now if we go to third figure, here we will compress spring. Compress spring. So see here, x is displacement, but it is along this direction. Along this direction. So it has direction. And force will act on the mass, and here force will act along this direction, means towards equilibrium position. Towards equilibrium position. So here force has direction. In first case force has direction, in second case also force has direction. So here force is a vector quantity. Vector quantity, and that force has magnitude also. We know in simple harmonic motion, magnitude of force, it is F is equal to kx. So this is magnitude and it has direction. In first case, direction it is along negative x-axis. In second case, direction is along positive x-axis. So force is a vector quantity. So here force is expressed in terms of direction as well as its magnitude. Now we will take another example. Suppose here we have body of mass m and here this is ground, and suppose it is held at some height from the ground, height h, suppose height h. Now what happens here? Here downward force will act on the body and that is mg. So it has direction downwards. Now what happens here? If we release this body will fall. This body will fall. So during its fall, it has acceleration as well as velocity. Now acceleration is constant, that is g, but it has direction. It has direction means it is towards, g is towards earth. Velocity it is also towards earth. And velocity it is what? Rate of change of displacement. So I will take this height as x, and when it falls, x goes on changing. And v we take velocity, it is dx by dt. So we take here velocity vector is d by dt, x vector. X is displacement. Dx is displacement in time dt. Dx is displacement in time dt. So v is equal to dx by dt. So this velocity here, it has vector, it is vector quantity and it has value at different places, and that is called magnitude. So here velocity is expressed in terms of magnitude as well as direction here. So these are some vector quantities. So here we will go to geometrical representation of a vector. Now suppose we have xy plane and let us take OP. So this is the direction and I will take this as a vector. So a vector that is along OP, so we can call this as OP vector also. OP vector also. OP vector. And magnitude of vector, it is nothing but, we will write like this, OP, that is length OP, that is length OP, length of OP, length of OP, that is called magnitude of vector. So here direction is along OP and whatever length, this length, it is its magnitude, it is its magnitude. So in this way we represent a vector. So vector has direction as well as magnitude. Now types of vectors. In general there are 10 types of vectors in mathematics, which are zero vector, unit vector, position vector, co-initial vector, like and unlike vectors, coplanar vectors, collinear vectors, equal vector, displacement vector and negative of a vector. Negative of a vector. So we will go one by one. So here we have seen OP is a vector. OP is a vector, or we can call that vector as a vector. A is equal to OP. And magnitude of OP, it is nothing but length of OP. Now here what is zero vector? What is zero vector? A vector A zero vector is a vector when the magnitude of the vector is 0. Magnitude of the vector is 0. Means here zero vector has zero magnitude. Zero magnitude means here whatever length of that OP, it is 0. Length of OP is 0 means what is meaning of this? What is meaning of this? Means here suppose we take vector AB, so point A, and suppose point B, so this is vector. Now length is 0 here, means what happens here? A and B both coincide with each other. That vector is called zero vector. So magnitude is 0 and initial point and final point, means starting point and end point, they coincide with each other. That is called zero vector. Now next one is unit vector. What is unit vector? So we have seen here vector OP or vector A and its magnitude, that is length of vector. So we define unit vector n, it is vector OP upon its magnitude, or it is vector A upon its magnitude, that is called unit vector. So if we take magnitude of unit vector, it comes out to be unity. Now see here, vector can have unit. So if we take force is a vector and suppose its unit is Newton. So unit vector for force, that is F upon its magnitude. So F upon its magnitude. Now F, it is in Newton, magnitude is also in Newton. So what is unit of n? N is unitless. So vector upon its magnitude, vector divided by its magnitude is called unit vector. Now this unit vector, here it is along the vector, means here it is along OP or along A. So unit vector. So it is along that corresponding vector and its magnitude is unity and it is unitless. Now next one, position vector. Now what is position vector? So here suppose we take here O is taken as a reference origin. So this O is reference origin. And A is this point, arbitrary point in space. Then the vector OA, this one, this one is called a position vector of the point A. This is direction of vector OA. So this is called position vector. Position vector simply denotes the position or location of a point in the three-dimensional Cartesian system with respect to reference origin. Here I have taken two-dimensional. You can take three-dimensional also. Third axis, you can take z-axis. Like this. So here position vector simply denotes the position or location of a point in the space with respect to a reference point. Here we have position, here we have point A, O is reference point, and this point A is in space, maybe in three-dimensional space. So OA represents position vector. OA represents position vector. Now next one is co-initial vectors. Co-initial vectors. So what is meaning of co-initial vectors? This one. So suppose this is x, y and z. It is three-dimensional Cartesian coordinate system, and O is reference point, or we can call it as origin. And suppose here position A. Okay, position A. Then we have two vectors. So I can take here position C. So this is vector C. And I can take here position B. This is vector AB. So we have two vectors, AB vector and AC vector. AB vector and AC vector. Now these both vectors have the same starting point, and that starting point is A. Starting point is A. So these vectors are called co-initial vectors. These vectors are called co-initial vectors because here their starting point is same, that is A. Starting point is A. So these are called co-initial vectors. So vector AB and vector AC are co-initial vectors. Co-initial vectors. Now next one. What is like and unlike vectors? Like and unlike vectors. So suppose we have two vectors, vector A and vector B. So suppose we will take here O and here A. So suppose this is first vector, vector OA, vector OA. And suppose we take another vector, B, and I can take here P. So PB. Here PB. So these are two vectors. The vectors having the same direction are known as like vectors. So they are along the same direction, along this direction. So these two vectors are like vectors. Like vectors along the same direction. So these are like vectors. Unlike vectors means suppose this is vector A and we have another vector that is opposite to A. So I will take this as vector B. So they are opposite to each other. Means their directions are opposite with respect to each other. So these vectors are called as unlike vectors. Unlike vectors. unlike vectors. Now next one is coplanar vectors. So what is meaning of coplanar vectors? So suppose we have three or more vectors. So suppose this is first vector A, suppose this is second vector B, and suppose we have third vector C. If these vectors lie in the same plane, suppose we take plane PQRS, it is plane, and these three vectors A, vector B and vector C, they may not be along the same direction, they may not have the same magnitude, but they are in the same plane. Their directions are different, their magnitudes are different, but they lie in the same plane. That vectors are called coplanar vectors. So these three vectors A, B, C are called coplanar vectors. But suppose we have case like this. Suppose this is plane horizontal plane. So this is first vector, this is second vector, but third vector is like this. Suppose C is like this. Then C is not coplanar with vector A and vector B because they do not lie in the same plane. So this is about coplanar vectors. Then we have collinear vectors. So here vectors which lie along the same line or parallel lines are known to be collinear vectors. They are also known as parallel vectors. So suppose we have here line, and suppose here we have first vector, vector A, and we can have second vector, this is vector A, and suppose we have another vector, this is vector B. They lie along the same line. So these vectors are called collinear vectors. These vectors are called collinear vectors. Now next one is equal vectors. What is meaning of equal vectors? So suppose I will take first vector from A to B, that is vector AB, and suppose we take another vector PQ vector. Now here direction of AB and PQ is the same. So here two vectors have the same direction, and if we take magnitude of AB vector, suppose it is some m, and magnitude of PQ vector, suppose it is also equal to m. So directions are same as well as magnitudes are same, then vector A, B and vector PQ, they are equal vectors. They are equal vectors. So magnitudes as well as directions are the same for two or more vectors. Then they are called equal vectors. Now next one, that is displacement vector. Displacement vector. What is displacement vector? Now here we will see displacement vector. What is displacement vector? If a point is displaced from position A to position B, then the displacement AB represents a vector AB which is known as the displacement vector. Means suppose I will take here two-dimensional Cartesian coordinate system. This is x-axis, this is y-axis. Suppose here this A is initial position, and suppose we place body here, and suppose that body is displaced and it goes here B along this path. So this is final point. So displacement is from what? A to B, and that is along AB. A to B, and that is along AB. So this AB represents displacement vector. Actually body is going along this path, but we consider here initial and final positions and along straight line AB. So direction is from A to B, and this vector is called displacement vector. Now next one is negative vector. What is meaning of negative vectors? So suppose we have two vectors. So I will take first vector. This is first vector. Let us call this as vector A, and I have another vector, and suppose that vector is B. That vector is B. Now if we take magnitude of vector A, and suppose it is M, and magnitude of vector B, that is also equal to M. Means I have two vectors, their magnitudes are the same, but exactly opposite in direction. So here vector A and vector B, they have the same magnitude, means same lengths, but their directions are exactly opposite. Then vector A is called negative of B, or vector B is called negative of A. And these vectors can be given like this: A is equal to minus B, or B is equal to minus A. You can write like this also. And if we take magnitude, you will get magnitude of A will be equal to magnitude of B. So A and B, A is negative of B, B is negative of A. So these are some types of vectors.